I am taking over introductions today because I have one big announcement from our fearless leader, James, has just received recently the Frederick Mosteller Award from the Campbell collaboration. The Frederick Mosteller Award is for distinctive contributions in systematic reviewing and is named in honor of Charles Frederick Mosteller, who was a professor of mathematical statistics at Harvard. And so we're just delighted that James has received this award. And so I wanted to make sure we all had a little chance to celebrate and congratulate him. And so, yes, that's so great. Yes.
Thank you.
Okay. No problem, James. We appreciate all your contributions. So it's also my distinct pleasure to introduce our speaker for today, Julia Littell. She is Professor Emerita from the Graduate School of Social Work and Social Research at Bryn Mawr. Her long career has included being the author of many evidence syntheses on processes and outcomes of complex behavioral and psychosocial interventions for children, youth, and families. She's worked in applied epistemology and uses and misuses of research in policy and practice. On a personal note, I find Julia's insights about systematic review and research to be, some of the most challenging and important things to think about when we are applying systematic review. And also on a personal note, all the work I've ever done with Julia has been some of the most important in my career. So without any more introduction, we'll have Julia start. We will take questions in the chat during the talk, and then there should be time left at the end for a discussion. So thank you.
Well, thank you, Terry. Right back at you. I mean, the best work I've done has been with you. It's been a real pleasure. What makes this work wonderful are the wonderful, smart, and lovely people to work with. So thank you so much. Thank you, James, for inviting me to do this. Thank you, Hannah and Caroline, for facilitating. And thank you all for being here. I'm really grateful to have this opportunity to talk about this topic, which I've been working on for, maybe a little less than a year. So this is very much a work in progress, and that makes it a really good time to talk about this for me. I'm looking forward to your comments and questions and our discussion at the end. So let me begin by saying, that my central questions here are really around whether we can or how we can use results of systematic reviews and meta-analyses to make inferences about the wider policy and practice contexts. And I'm going to refer to these kinds of reviews as SRMAs or just sometimes reviews, but that's always what I mean. So I'm going to focus today on reviews of research on intervention effects, because that's the area that I've worked in, but you could also think about problems of generalizability in relation to other kinds of reviews. I mean, certainly it's relevant in thinking about reviews of research on associations or incidence and prevalence, important topics to think about generalizability there, but we're not going there today. I'm using the term generalizability and the term external validity somewhat interchangeably. To me, they mean extrapolation beyond the data at hand. And that's a definition that I get from Shadish, Cook, and Campbell, which I'll come back to. And so to me, this means what populations, problems, interventions, comparisons, outcomes, times, and settings, I'll use the PCOTS rubric as shorthand for that, to what PCOTS are the results of our review likely to apply? I'm also going to talk about applicability, which means to me a relevance of results of a review for a specific target context. And here the question is often from the perspective of a specific policymaker or practitioner. What are the likely effects of this intervention in my home, in my context, with my people? So we're talking about generalizing from what Campbell called one set of multi-attribute contexts, that is, studies and reviews that have many complex characteristics, to other sets of multi-attribute contexts. This is a complex cognitive task, and I'd want to make a distinction between generalizing from reviews to the wider world, in which we have to think about which kinds of settings, populations, comparisons are relevant. I think it's a slightly different cognitive task than thinking about application, where you're often beginning with a known setting, known P-codes, looking at a review and saying, well, which, if any, of these results are relevant for my situation, and then going back. So there's a little more back and forth. It's a different, I think, cognitive task with some very similar underlying issues. So I'm beginning to think about this as generalizability assessment. That's, how do we assess the generalizability or applicability of results of a SRMA? And my first question to you all is generalizability assessment really a thing? I mean, I've run across this term in the literature, but every time I see it, which is not very often, I've never gotten a description of what it means. So we often are told, look at the generalizability of your findings, look at the P-codes. Great. How? Then what? So I think it ought to be a thing. That's what I'm working on here, and you'll see my rough work on this. I think it ought to be parallel to what we now think of as evaluability assessment, which is a process used to determine whether and when interventions are ready for rigorous outcome or impact evaluation. Peter Rossi and his colleagues have done a lot of work on that over decades, and they suggest that before you subject an intervention to a rigorous outcome or impact evaluation, there's certain prerequisites that ought to be in place. The program ought to have a defensible logic model or theory of change. It ought to have good descriptive data on its participants, intervention processes, and outcomes. Maybe that's a single group study, fine, but something. The program should be running smoothly for at least a year so that evaluation is not running into implementation problems. And Peter Rossi said, evaluate no program until it is proud. And what he meant was that we shouldn't waste time studying programs that are floundering. There's nothing to be learned from bad programs, that you want to evaluate programs that really have something to teach us. So I'm suggesting that maybe generalizability assessment could be something parallel to that, where there's some ideas about prerequisites for generalizability and some principles. So I have been developing some thoughts on this by muddling through, and I'm hoping that you all can help me refine this and advance this a little further. And in today's talk, I'm muddling through by talking about two case studies. These are two SRMAs of the effects of two widely disseminated evidence-based programs. And I'm drawing on three frameworks for thinking about generalization: probability theory and sampling methods, principles of generalized causal inference from Shadish, Cook, and Campbell, and then common rubrics and rhetoric used to think about generalization. So our two case studies are reviews of the effects of multisystemic therapy and functional family therapy, which I completed with my dear friend and colleague, Terry Pigott, and other people. And these reviews, I said, are of prominent evidence-based complex psychosocial treatments for families of youth with social, emotional, and/or behavioral problems. And what I mean here is that if you look at any list of evidence-based or effective programs for families of youth with these kinds of programs, you will find MST and FFT at the top or very close to the top, anywhere in the world. So these two interventions have something in common. They're short-term home and community-based treatments that use techniques that are really borrowed from various cognitive, behavioral, and family therapies. They involve family social networks and other social service systems. And they're branded interventions in that they require training and licensing by companies, limited liability corporations, that are founded by the program developers. They make strong assumptions about the proven effectiveness of these treatments and their generalizability. So let's begin by looking at some of those generalizability claims. I'm not going to read this all, it's too much words, but I'm going to hit the highlights to give you a flavor of the kinds of claims that have been made about the generalizability of these interventions. It's said that the effectiveness of MST has been demonstrated across problems, therapists, and settings, that MST is superior in improving outcomes of various kinds and in comparison to a variety of other treatments. It's said that the FFT outcome studies demonstrate the effectiveness of this treatment with a wide variety of adolescent problems over time, with different populations, on different outcome measures, and in comparison to various control conditions. So you get a sense of the kinds of statements that are out there. So I'm going to proceed to talk with you about what I'm thinking about for a generalizability assessment around 4 questions, and we'll go through each of them. But my first question is, do the sampling methods or the representativeness of the samples that we have support broader generalizations? So here we call on probability theory and what we know about sampling methods. And of course, we know that probability samples are the gold standard for generalization from sample data to a larger population, because probability theory supports the use of inferential statistics to estimate population parameters. But the types of studies that are often included in SRMAs of intervention effects, that is, randomized controlled trials and quasi-experimental designs, rarely use probability samples. Even when they do, a bigger problem is that the reviews themselves do not use probability samples of studies from some larger population of studies. So let's think about this sampling problem. Think about a hypothetical universe of all relevant interventions. So for my 2 case studies, this could be all MST programs or all FFT programs. Some of these programs have had no impact evaluation. In fact, most of them have not. Some are evaluated with quasi-experimental designs, and a few are evaluated with RCTs. When we come to taking a sample of studies for SRMAs, we want to get all the studies that are out there. If we do that, we're looking at a sample of available impact evaluations, if we're including multiple designs, and programs that have been evaluated are not a representative sample of all relevant programs. If we refine our eligibility criteria and limit our review to randomized controlled trials, we have a smaller sample, and again, programs evaluated with RCTs are not representative of all programs that have been evaluated. So let's see how this actually works out in the MST and FFT worlds. I'm not going to, I'll help you read this table instead of making you look at all these little numbers, but worldwide, there are 558 MST programs that meet our eligibility criteria, and they're located in 15 high-income countries, most of them in the USA. And there are 23 MST trials in 6 of those high-income countries. So right away, you see that many countries that have MST programs are not represented at all in our review. And that's a little bit problematic when it comes to Australia, the Netherlands, and Norway, where there are a lot of these programs that are not well represented in our review. So I said that most of the MST work has been done in the USA. 80% of the programs exist here. 70% of the trials are in the USA. So let's take a closer look at MST in the USA. That's what this looks like. 440 programs in 34 states, 16 trials in 7 states. But look at this. 2 states, Missouri and South Carolina, where the MST developers live, have fewer than 1% of all MST programs that exist in the US, and they account for almost 63% of the American trials. These 2 states, Missouri and South Carolina, account for 43% of all the MST trials in the world. In FFT, it's very similar. We have 334 FFT programs in 12 high-income countries, 20 evaluations in 6 countries, most in the US. So in the US, we have less than 300 programs in 38 states plus DC, 15 evaluations in 8 states. And again, there are 2 states where the FFT program developers live. This time it's Indiana and New Mexico that have about 1% of the programs and more than half of the evaluations in the US. These 9 evaluations account for almost half of the FFT evaluations in the world. So that's the sample we've got. Do these sampling methods support broader generalizations? My answer is no. Not to the world, not to countries in which MST and FFT have been implemented. Because probability theory provides us with no basis for generalizing from the results of reviews that are based on non-probability samples of studies when the studies themselves use non-probability samples of participants. And our analysis that I just showed you suggests that indeed these studies are not representative of programs in the countries or states in which they've been implemented. Okay, we're not done yet. What's our confidence in the pooled estimates that were produced by our reviews? Because I think to think about generalizability, we've got to have some confidence in the estimates. So I'm thinking of this as a likely prerequisite. We can think about the confidence of results in several ways. Here are our risk of bias ratings from the 2 reviews. And these are aggregated so that what you're seeing here are the percentage of studies that in each review that had low risk, unclear risk, and high risk of bias. There are a few cases where studies didn't collect the kind of data that we're interested in, so they're not applicable. We find high risks of bias in more than half of the studies on baseline equivalence, selective reporting of outcomes, and conflicts of interest. If you look study by study across all these risk of bias categories, you find that almost all of the MST trials and all of the FFT studies have high risks of bias on at least one indicator. Next, we look at consistency of effects and coverage. So the prediction intervals suggest that future studies are likely to find a wide range of positive and negative results. And we have somewhat uneven coverage on outcomes. So there are some outcome domains in which most studies report some data and others in which the data are sparse. And this is a big problem in the FFT review, where there's really sparse data, so much so that we can't even calculate prediction intervals in some outcome domains. Okay, we also use grade ratings to think about confidence in results. And for MST, the grade ratings or the certainty of evidence for the primary outcomes were moderate to low, meaning that further research is likely to affect confidence in the estimates of effects and might change those estimates. For FFT, the grade rating low for all 6 primary outcomes, meaning, according to grade, that any estimate of effects based on available data is very uncertain. So, lacking confidence in the evidence for FFT, we conclude that results are not generalizable beyond the studies in the review. And I stopped the evaluability assessment for FFT there. I don't have confidence to go further. Our confidence in MST is moderate to low, but I'm going to proceed because I'm really more interested right now in this process of evaluability assessment, in its logic, and seeing what we can do with other approaches to generalizability. So, next question is, what can we learn about the generalizability of effects from sort of an internal analysis of heterogeneity, subgroup, and moderator analyses? And that's going to inform the last step in this process, which I think of as maybe is the most important. For MST, we find that effect sizes tend to be larger in studies conducted in the USA by MST program developers and in studies with high risks of bias. And these moderators are almost completely confounded, so that the studies conducted by program developers are in the US and have high risks of bias. We just cannot unravel that. So it's not possible to explain observed differences in effects between subgroups formed by these variables, and there are some. So it looks sort of like this in a forest plot. It's not always this neat in our forest plots, but here's the effects of MST on out-of-home placements of youth at 1 year after random assignment. The first set of studies are all conducted by MST developers in the US. The second set of studies are all conducted outside of the US by independent teams. And you can see that there are more concerns about risk of bias in the first set. You also see that there are significant effects in the first set, but not in the second. And we have unexplained heterogeneity in both subgroups. Another important observation about heterogeneity comes from an analysis of some of the contextual differences that might affect outcomes in these studies. So two of the most important outcome measures here are arrest or conviction of youth and out-of-home placement of youth. And we see that overall MST is associated with small reductions in the risks of these outcomes, but they're not the same in the US versus outside of the US. I just showed you that forest plot. And on placement, MST is associated with a reduction in the risk of out-of-home placement in the US, which is generally viewed as a good thing, while it's associated with a slight, not significant increase in placement outside of the US. So things are not the same. And the reason might be this. When we look at what happens in control cases without this MST intervention, almost half of the youth in control groups in the USA are arrested or convicted within a year of random assignment, and 40% are removed from their homes. Outside of the US, those events are not as common. So fewer than 30% of youth are arrested or convicted within a year, and fewer than 20% are placed out of their homes outside of the US. So this intervention is operating in very different contexts, and that's important. So now we get to, I think, the heart of the matter, and that's applying principles of generalized causal inference here. This is from this book by Shadish, Cook, and Campbell, 20-some years old now, but I still love it almost as much as my students have hated it. But okay. Apologies to all doctoral students everywhere. A main takeaway from this book is that validity, which I think is the heart of the matter here for any kind of research, is a property of knowledge claims, that is, inferences or conclusions based on data of research methods. And by extension, external validity or generalizability is a property of certain kinds of inferences, extrapolation based on data. It is not just a property of probability sampling methods. And that's why I'm willing to continue with this exercise beyond showing that we don't have representative samples. So the logic of generalization, then, is really a conceptual problem that ought to have good empirical reference. So how can we transfer knowledge developed, again, in one set of multi-attribute contexts, that is studies, to another set of multi-attribute contexts, that is targets for generalization? And a long time ago, Donald Campbell said, we need something more appropriate than the generalization rhetoric and the solution of it by representative sampling from a universe designated in advance. And in this shift, the validity of theoretical interpretation replaces a theoretical generalization. Well, maybe. Let's see. So here are the principles that Shadish, Cook, and Campbell laid out for generalized causal inference. Beginning with proximal similarity, they changed the term to surface similarity in 2002, which I'm not a big fan of that, but proximal similarity is the principle that's discussed most often. The others, it's really rare to find discussion of the other principles in work on generalizability. But proximal similarity means, for Shadish, that we generalize most confidently to applications where our p-coats are most similar to those in the original research. So you often see illustrations like this one showing different dimensions of the p-coats and suggesting that the closer a context is in terms of similarity to our study, the more likely it is that results will be generalizable. And this is important in several ways. First, in reminding us that external validity and generalizability are not dichotomous variables. It's not either or. It's not generalizable or not. It's how confident are we in our generalizations? And the closer, the more similar people, places, times, and treatments are to those in our studies, the more confident we are that the results apply. Great. But which gradients of similarity matter the most? I don't see much discussion of that. We could begin with the p-cots. Certainly those are worth thinking about. There may be others. I think that a first step here in at this phase of generalizability assessment is to decide which p-cots matter in the context of a particular research question and a particular review. And then once we've done that, what variables or factors should define each gradient? So if I say, well, population matters, it almost always does. What do I mean? What population characteristics are important? Age, gender, ethnicity, what? And so I imagine that we might come up with some sort of n-dimensional comparison space where n is the number of variables or factors on the gradients that we've decided are salient. Not a statistician, but I'm sure that some of you in the audience can help me with this problem. So I think that for the purposes of MST, I'm suggesting that there are maybe 5 relevant gradients of similarity. I'm dropping out the time factor because I don't think we have anything to say about that. Maybe that's a mistake, but that's where I'm at now. And we can say that to be similar to the studies in our MST review, we're talking about families of youth with social, emotional, and behavioral problems, short-term home and community services, in comparison to treatments that vary in terms of the amounts and types of services that are provided. In terms of outcomes, what's important here depends a lot on stakeholder goals. So this intervention is used to accomplish a lot of different things. We see that in the research. That's why there's uneven coverage of outcomes. Some researchers are interested in some goals and not others. And then in terms of settings, we're really limited here to the weird countries, which you may know are Western, educated, industrialized, rich, and democratic, because those are the only places this treatment has been studied. Okay, so that's sort of the heart of the p-coats that we're talking about. Now what? What can we learn about these gradients based on the study data? And unfortunately, the short answer is not much, because descriptive data are often not comparable across studies. I'd like to be able to look at comparable measures of things like socioeconomic status, or household income, or poverty status, household composition, but the measures used in these studies when they look at those issues are so diverse, there's absolutely nothing comparable. The comparable data that we have on descriptive characteristics are, to my way of thinking, either superficial or sparse. We have some data on treatment duration in days, both for MST and for comparison conditions. And we have some data on the amounts of service provided, meaning hours of contact, but that data is sparse, and it really doesn't tell us what's going on in these interventions, okay? The data that we have on participants also are the things that are easy to collect: age, gender, and race. And then, as I said before, we have uneven measures of outcomes across studies. Okay, Shadish, Cook, and Campbell said that proximal similarity is necessary but not sufficient for generalized causal inferences. It's a good starting point, maybe. And Campbell said that perhaps the principle of proximal similarity merely describes the route, I would say a route, to theory-based generalization. Maybe it gets us thinking about what kinds of comparisons we need to be making, but we need the other principles to flesh out generalizability assessment. So let's see where we go here. The second principle is called ruling out irrelevancies. We generalize most confidently when a research finding continues to hold over variations in PCOTs that are presumed to be conceptually irrelevant. Okay, what does that mean? What variations are conceptually irrelevant? I think you have to address that question again in the context of a specific research question or a specific review. So for the MST world, that program clearly claims that none of the PCOTs are irrelevant, and there are published claims that effects are robust across all of them. Okay, well, our systematic review refutes those claims by showing that results are inconsistent within and across studies and inconsistent across the PCOTs. Next, a principle they call making discriminations. I prefer discriminant validity. We generalize most confidently when we can show that it is the target construct, not something else, that's necessary to produce a research finding. Can we do that? No. MST treatment is confounded with other variables that might account for any observed effects. So in the trials in our review, excuse me, MST cases received more time, more service, more attention than control cases. MST therapists received more training and supervision than workers who provided service to the control cases. So the trials have not ruled out confounding factors, time, attention, training, and supervision as possible explanations, and they really need to do that. So there's a direction for further research. There are another set of obstacles is that there are what are called fidelity measures that are used to assess the extent to which program providers are adhering to this MST model. But these measures really lack face validity, content validity, and discriminant validity because the content is confounded with other variables known to predict outcomes like alliance, satisfaction, engagement, and even outcomes. And these measures have not been shown to discriminate between MST and any other treatment. So we're getting nowhere on this principle. The next principle has to do with interpolation and extrapolation. We generalize most confidently when we can specify the range of PCOTs over which the findings hold more strongly, less strongly, or not at all. Can we do that? No, because moderators of effects of MST are confounded, and as I said before, there are unexplained variations within subgroups, and that's again this problem. We can't say that studies in the US show one thing. Even in this forest plot, the first 5 studies were all conducted in South Carolina, and we can't really say anything about effects of MST in studies conducted by Hengler in South Carolina. Okay, so we move to another big issue, and that's causal explanation. I'm happy that we land here because I think we have a lot of work to do here still. We generalize most confidently when we can specify completely and exactly which parts of one variable are related to which parts of another variable through which processes with which interactions, because then we can transfer just the essential components to a new application. Seems like a wonderful goal, but we can't get there today with MST, because the MST theory of change is, I would say, underdeveloped because it does not fully explain the hypothesized effects of this treatment, and it doesn't account for actual inconsistent results in studies and reviews. Okay, so I have talked through what I think are some important components of generalizability assessment. Let's look at now at how these treatments did. So here's a sort of review. I'm looking at support for generalized causal inferences for MST based on the criteria that I've talked about. We get no support in terms of representative sampling. The certainty of evidence is moderate to low. I worry about that. I think there ought to be some threshold for generalizability. I'm not prepared to say what that should be because I'm not a huge fan of the grade ratings myself, but this would be sort of a low bar. I was willing to go ahead with moderate to low evidence. I'm questioning whether we should go ahead with low evidence. But for the other criteria, our support is either unclear because for proximal similarity, we have insufficient descriptive data, or it's no support at all because we can't rule out irrelevancies. We don't have discriminant validity. We can't disentangle moderators or explain variations in subgroups, and we don't have support on causal explanation. The FFT situation is a shorter story. No support for probability or representative sampling, very low certainty of evidence, insufficient data to go further. So this is disappointing, but again, it's the process of thinking about generalizability that I'm most interested in here, in developing here. And maybe these are not fabulous examples, the reviews that I've picked, but I think we can say that, maybe we can say that the results of FFT and MST are not widely generalizable. I think I'd rather say that I'm not confident that these results are generalizable. I think confidence ought to be a word in that sense here. We can certainly say that we need better primary studies with lower risk of bias to control for factors confounded with treatment and provide better descriptive data. So there's a whole lot of work for the next generation of primary studies. And I think that while it's difficult to generalize from our reviews to some wider set of context, this idea of application, at least for MST results, to specific context might be feasible. This seems a little more realistic to me, that if we begin with knowledge of a particular context and then look at the MST trials and identify those that are most similar to our situation, we would first, I think, assess the credibility of estimates produced by that set of trials. And if we're confident enough, whatever that means, those trials, reanalyze the data, if it's possible, and estimate likely effects based on this selected subgroup of studies. And this is an approach that was proposed by Shackelford and colleagues a while ago, an approach that they called dynamic meta-analysis. They're working with a much larger data set, so it's actually possible to do much more than we can here with our small reviews. And, of course, an obstacle here is that we have very little statistical power for subgroup analyses in the MST review. Let's turn now to looking at more common rubrics and rhetoric regarding generalization. Commonly, I see use of the mean effect size or a rating based on the mean effect size as the best available estimate of likely effects of an intervention, often presented without confidence intervals or prediction intervals. So, for example, the Youth Endowment Fund, which is a prestigious group in the UK, I think I would call them knowledge brokers. They produce an online toolkit. It's described as a free resource to help you put evidence of what works to prevent serious violence into action. So it's clearly aimed at applications. And inside the toolbox, you'll find our multisystemic therapy. And you can see that its estimated impact on violent crime is described as moderate. What does that mean? We drill down into the technical report behind that rating, and it says that the review estimates that MST reduces offending by 17%. And it says that that estimate comes from our meta-analysis of data on arrests or convictions at 1 year, which I actually have shown you. That's incorrect. The overall risk difference is 3%, not 17, and it's not statistically different from no effect. But that's not mentioned, and there's no confidence interval, no prediction interval provided with this estimate. This approach is very consistent with what the American Psychological Association and the Society for Prevention Research guidelines say in thinking about identifying effective treatments that are ready for broad dissemination. They focus on positive pooled effect sizes without specifying the magnitude of an effect size or whether it's okay if the confidence intervals or prediction intervals include null or negative values. So I think mean effect sizes are relatively uninformative for purposes of generalization. Of course, they ignore heterogeneity, confidence or credibility of estimates, risk of bias, subgroup differences, moderators, all that. And I'd like to say that mean effects may have no real meaning anywhere in the world. We see in the MST case that this is an intervention that's operating in two very different contexts, the US and other weird countries operating very differently. So an average of effects across the US and other countries has no real world referent. It doesn't mean anything to me. And when presented without a confidence interval or a prediction interval, point estimates convey what Charles Mansky called incredible certitude. I think that's a nice phrase, because credible estimates are provided within a range. The world is uncertain. We know this. So there's a related story, rhetoric about bridging the no-do gap. So it's said that what we know based on research and what we do based in practice and policy are too far apart. And you'll often hear the statement that on average it takes 17 or 18 years for a well-established research finding to find its way into a routine practice. So the concern is about bridging this gap, and that's led to these fields of knowledge translation and implementation science. And there's an awful lot of rhetoric that is basically using the Nike slogan, just do it. Take the research and do it. With program manuals, training, fidelity checks, knowledge translation, implementation, and knowledge brokers like Youth Endowment Foundation, we can take the moderate effects of MST and roll it out around the world, and we'll solve some problems. So I think that's wishful extrapolation, another wonderful phrase from Charles Mansky, wishful extrapolation. Because what's in this gap is a whole lot of unaddressed questions about generalizability and applicability. And this is what we don't know. And we ought to be honest about that. We ought to be moving those issues into research, addressing the questions, and we ought to be honest about that in terms of policy and practice so that decision makers understand what it is that we don't know. MST does not reduce violent offending by 17%. I'm sorry. But SRMAs can identify gaps in knowledge and directions for further work. And that's what I've been trying to do here. Generalizability assessment might help, even when the results are so disappointing as they were in these two cases. So wrapping up now. Conclusions. Do pooled estimates from SRMAs have greater external validity than study level effect sizes? My short answer is not necessarily. A medium answer might be probably not often. The long answer, a better answer, I think, is that the logic of generalization from SRMAs is really underdeveloped. How can we use reviews to inform inferences about generalizability? Well, certainly we can test generalizability claims, and that's a good use of this work. We can use subgroup and moderator analyses to help us understand constraints or limits on generalizability and apply principles of generalized causal inference to further inspect SRMA data and think about issues of generalizability. And then we can identify directions for further work to address unanswered questions about generalizability. And we need to pay more attention to the logic here. So thank you so much for your time. I'm looking forward to your comments and questions and suggestions.
Yep. So we're happy to take questions over the chat or over Zoom if you just raise your hand. Looks like we've got a question from Tyler. Go ahead.
Yeah, Julia, this was really, really great. And it's fun to see, that this all leads back to Shadish, Cook, and Campbell, which is, I guess, not surprising, but it was really, really helpful to hear you talk it through using their language and their reasoning. I wonder if you could apply just how you would think about this framework that you laid out to meta-regression work. So, if your inference is really based on meta-regression results, how can we think about the generalizability of those?
Nice question. That's great. I haven't thought enough about that. Because we have these small reviews that I'm working with, but I would say that you ought to pull it apart in the same way that I've done before you get to generalization. So think about, I think the general principles that I was talking about for generalizability assessment apply. Think about the sampling. Think about what's the basis, what's the logic for generalized inference here. Do you have a basis from sampling? Are you confident in the estimates? What do you know about heterogeneity of effects and moderators from the meta-regression? That can help you with that. And then how do you think about these principles for generalized causal inference? I'm not sure I'm going to stick with the Shadish, Cook, and Campbell 5 principles, but it's not a bad place to start. At least it got me thinking and it helped me articulate what I think are some concerns about generalizability. I think you could do the same thing with meta-regression. I don't know. If you have a better idea, let's hear it.
Oh, no, I'm just thinking about work that we're doing in my lab right now. And it seems like when I think about this, it comes back to sort of the same types of things that you think about when you run a regression on any sample, a sample of participant data, or a sample of, you're sort of wondering, look, does the inference from this regression, would it apply to different units, people, settings, and you kind of have to think through, well, what sources of heterogeneity could there be that I don't have represented here that would really change the result of this slope term or intercept term or whatever it might be that you're getting out of that meta regression. So it seems like you're into a similar set of issues, but ultimately, I guess you also want to know if I'm designing a new intervention and I look to your study and look to the results of your meta regression and find inference for myself there on what I should expect to see with my new study that I'm doing. It seems like that's an important kind of test to ask yourself, but it's hard to answer, obviously.
Exactly.
So.
Well, listening to you talk is really helpful, Tyler. I think in addition to maybe some of the concerns that I laid out here, you have others in meta regression. Are you meeting the assumptions of the model, meta regression models?
Right.
So there's some additional questions that I didn't pose here, and I keep coming back to this problem with causal inference. I don't think we're thinking about that very well. We think about causal inference in terms of this sort of linear cause and effect model, which was outdated a long time ago. And if you look at what some of philosophers of science are doing, is that they're thinking about this in much better ways. I think about Nancy Cartwright's work at the London School of the LSE, London School of Economics. She says, if your question is, will what you're modeling in your meta regression apply to my situation? Will it work for me? You can't get that from a meta regression. You can't get that from a randomized controlled trial, because there are many possible routes to the same outcome. And so Cartwright talks about causal inference in terms of causal pies. She said you can make lots of kinds of pies. You can make blackberry, blueberry, pecan. They all might do the trick, but they have different ingredients. And so just because you're doing one intervention, or you have one context or one population and you get one outcome, doesn't mean you need the exact same ingredients. You might get there with some other combination of pecots. And we're not thinking about that enough, I think. So I think Nancy Cartwright's really on to some much better ways of thinking. I think we can pursue understanding of causal inference and generalizability in systematic reviews and meta-analysis, in meta-regression. But we need to be really thoughtful about what we're doing and try to break it down into, to examine the assumptions that we have, the nature and quality of data that we're using. And I think that too often people are doing meta-regressions and meta-analysis, pairwise meta-analysis, without really talking about the sampling issues, the quality of the data, and that stuff really ought to come first.
Thank you. Very, very helpful.
Thank you. Great question.
Julie, I had a kind of a related question. One of the things that I thought was really interesting about the examples you gave is how you used essentially like ancillary data from the studies on like base rates for some of the outcomes to make an argument about, I guess, proximal similarity, right, or the generalizability
Yes.
from one context to another. I think that's really intriguing. It's like, it seems like there might be an argument there that we need to be paying attention to features of the studies other than the average impact estimates to make these judgments. And so I guess I wonder if there's like other aspects or like other ways that you've made that argument, other pieces of data within the studies that could be useful for informing these judgments.
Great question. Yeah, I think that the base rates, that's a really important lens that we just kind of stumbled upon in this review, trying to figure out what can we do to untangle these crazy confounded moderators. And that little piece of information provides a very important potential explanation for some of our results. So yeah, it probably ought to be routinely looked at, and I've never seen it looked at before. And yes, there are other things that we can look at. So we didn't have good data on the duration or amounts of contact, amounts of treatment provided in MST, but especially in the comparison group. But we were able to use a lot of the statements, and I guess I would call some of this data anecdotal, but it was repeated in a lot of the MST reviews, particularly reviews conducted by program developers. They would say the MST cases got a lot more time and attention. Our therapists are, the best and well supervised. And so we don't have good hard data on that, but we are using other kinds of statements to help our understanding of why this complex program works differently in different complex environments.
Okay. The other thing I wonder about is, and maybe this is a challenge for your ongoing work in the area, would be, do you have a positive case? Right? A positive case study, right? I'm kind of getting anxious here.
Yes.
About whether anything that I'm doing is worthwhile. So are there like or either like a existing case or like a hypothetical case where you could see there being a really strong warrant for generalization?
That's the perfect challenge for me, James. Thank you. I really don't want to go further with this kind of work without something like that, because it otherwise it's just doom and gloom. We don't need that. So right. I mean, there must be some positive cases, and I will go find them. I mean, there must be. And I gave an earlier version of this talk at SRSM this summer. It was much more simplistic, I think, than what I have now. And I could just feel the shivers in the room. It's like, oh my God, do we really have to talk about our samples? Do we really have to do? So yeah, we need positive examples. Absolutely. They must exist.
Kimber?
Sure.
Yeah.
Hi.
Thanks for your talk. This has been fabulous. Hi, James. Good to see you. I'm wondering if there's been any exploration that you know about for us to try to reverse the order of making things make sense after the fact, and instead for certain types of studies that we know are needed, or meta-analyses that we know are needed, to rather suggest a protocol where people would at least fill in the information. It may or may not be what they're going after for their particular study, but to somehow register this as a crowdsource type of, please describe your participants in this way, or check off these boxes, or please look for these, please add additional information on moderators or setting conditions, or please describe your intervention as one of the following 5 buckets or categories, so that people could come in afterwards, and at least people who are doing the original studies would be attempting to write them in a way that they could be aggregated later or used.
Great. That's a great idea. There's some work in that, particularly in medicine, on common outcome sets. People are asked to define outcomes in certain buckets. And there's some work in terms of describing interventions in comparable ways in something that's called the tidier statement, TIDIER, making it neater, but describe your intervention in this way, please. But you've expanded on that, and that's lovely. And there are some groups that have templates for protocols. I'm not sure that they're as explicit as you might like. I think it's a great direction. It's a task.
I think our field is almost the other direction, that we're asked to present how is this intervention novel in some way, or completely new or different, or adds a bell or a whistle or a component, or the population is different. So we're perpetually seeking the new and novel, and not really for purposes of publication as opposed to purposes of science or the integrity of a larger body of studies.
Yeah, it's the replication problem. People don't want to replicate, they want to do new things. But we have to have a language that's comparable to accumulate evidence properly. We have to be able to build on studies using, comparable constructs and data. It's a big gap.
Thank you so much.
Thank you.
Wolfgang.
Yes, hello. Thanks for this very nice presentation and really raising a super important issue. So given my background, of course, I'm going to think about this like from a more statistical perspective. And I think we actually had a little bit of this discussion at the SRSM meeting. So an approach that I could imagine could be valuable, and I think is not really used that much currently, is to use these best linear unbiased predictions of study-specific true effects. So if you can identify a study in the pool of studies that you have that is similar to sort of the context that you are interested in, and so then instead of focusing on the average effect, you actually get this sort of predicted effect for the true effect for that particular study. And then you can use that maybe as a much more informed estimate of what you might see in under the circumstances that you're in, which relates, for example, to like looking for similar base rates. And well, of course, country matters. So maybe you're just going to start to ignore studies from other countries which are not relevant. But the nice thing about these blobs, these best linear unbiased predictions, is that to the extent that there is heterogeneity, it's sort of automatically factored in. So if there is little heterogeneity, well, yet then actually the blob is almost like the average, right? Because if there is little heterogeneity, who cares, right? I mean, then you can take that average. But if there's a lot of heterogeneity, well, then you really shouldn't be paying attention to that average, and then identifying one sort of study that is most close to your context is maybe what you should be doing, and then the estimate that you get is mostly just determined by what you found in that particular study.
Wonderful.
So it's just something that I'm thinking of that could be like a really nice strategy, sort of statistically, but also conceptually, to address this problem.
You did mention that this summer, and I need to learn more about that. You're saying that you can do this with one study.
Well, so you do a meta-analysis, and and then you can predict for each study what its true effect actually is. And it's a compromise between what you actually observed and what the average effect is. And to the extent that there's a large amount of heterogeneity, you're mostly sticking to the observed effect. If there's little heterogeneity, you're basically almost, so it's like kind of a combination of the observed effect and the average. And tau, or the amount of heterogeneity, determines like where you're putting the emphasis.
And are you modeling it based on known moderators?
So no, actually you don't. Okay. So I mean, that's you can also bring in moderators here. But so if you are fitting a meta regression model, then you can also compute blobs. That is definitely possible. So but even before that, you could just say, well, without moderators, you still have to think about what are relevant variables to think about, right? So so this proximity of studies, right? So what is sort of the study that is closest in some sense to the circumstances that I'm worried about, or thinking about where a particular treatment is going to be used. And well, yeah, you have to think about this, and that's a challenge, of course. But well, I mean, to start with, given what you talked about, I would say, well, first look for studies in your own country or close by, where participants are similar in terms of demographics, et cetera, right? So, yeah.
Mm-hmm. So Wolfgang, you're talking about applicability, not broader generalizability.
Yeah, and so I guess that's a good point, right? So I'm more thinking of like, okay, well, I mean, I think these two things are related, right?
Sure.
You want to generalize, so you have a feeling of, can I use this information in my setting, right? But we could also say, well, let's forget about generalizability. Let's just sort of find a study that is kind of similar to what I'm concerned about. And so whether other studies like are representative is less of a concern then.
Yeah, I think this is a very important conceptual issue, though, because I'm also with you that I think that we're going to get more traction working on applicability from a local context. I think that's much more feasible. And I think that's what knowledge brokers ought to be doing. They ought to be helping policymakers and practitioners saying, okay, well, what's your context? You're the expert on this. Tell me about your PCOTs, and let's go see what we can find for you. They're not doing that. They're doing this top down. Here's the mean effect size, go do that, which is stripped of a lot of information. So I'm gonna look into the BLUPs, and maybe hopefully the next time I see you, I'll be able to ask you more intelligent questions about that. But I think it's a real way forward for applicability. It doesn't apply for external validity in general, though, right? Am I understanding that part?
Yeah, I mean, I haven't really thought this all the way through, right? I'm sort of shooting from the hips here.
Okay.
But yeah, I would say it's really more about applicability than generalizability. Although, again, I think there's some links here between these.
Of course. Maybe we care too much about generalizability and not enough about applicability. Maybe that's part of the problem.
Well, if we can solve one problem, then let's just find a problem that we can solve, right? That's
Bloops, you did it. Okay, positive example. Thank you.
I do want to be conscious of time. So Julia, thank you so much for coming to share this work. I think it's really important.
Thank you.
And thank you for joining us. We'll be back next month, kind of shifting gears a bit to talk about selective reporting, publication bias adjustment methods. Thanks all for coming.